All right, you chemistry students, we are coming to our final bit to our first chapter / unit on dimensional analysis, sig figs, etc. All right, so we're going to focus now our attention on these complex dimensional analysis problems. So we're going to add a few layers of complexity to what we're doing. Now, a couple bits of information. Number one thing to think about is if you can do these, you will be able to do anything else we do this year. Nothing we do this year will be really any more difficult than what I'm throwing at you with these more complex dimensional analysis problems. They'll be different, and there'll be some learning that you have to do with it. But if you can accomplish this and tackle these and figure these out, you have the skill set necessary to do much of what we're going to do. So good news is nothing we do this year will be really any more difficult than what we're doing right now. All right? So when I say a complex dimensional analysis problem, what am I talking about? Well, really it's two things. First of all, maybe we have a problem in which there's more than one unit to convert. All right, so I'm just going to do this as examples. Let's say I'm traveling at a speed of 45 kilometers per hour. What is my speed in meters per second? So in this case, there's more than one unit to convert because I'm going to convert in kilometers to meters and then hours to seconds. So it's going to be a two different conversion problem. So this is where that table method I've been showing you kind of comes into play, because we can complete all of our conversions all in one table instead of having to do multiple different setups and different calculations. So I'm going to demonstrate. So my first step, I'm going to take my known quantity, which is 45 kilometers per hour, right? Now I have two units attached to my 45 kilometers per hour. So my first thing I'm going to write is 45 kilometers over 1 hour, right? So at that speed, essentially what that means is I will be able to travel 45 kilometers in 1 hour's worth of time. All right? Now, I'm converting my speed to meters per second. So what I have to do then is decide, do I want to convert kilometers to meters first or seconds to hours first, or hours to seconds, excuse me. Doesn't really matter. All right. Now, in this case, I'm just going to go ahead and go kilometers to meters first, right? Because that's a metric system. I've done that before. So I'm going to go kilometers on bottom and meters on top. That's just using that method I've already shown you guys, right? Now, am I going from a bigger unit to a smaller unit in this case? Yes, I'm going from kilo down to meters, which means I will be multiplying by my difference in magnitude. So hopefully you guys have your conversion table for metric system in front of you. If not, you should be able to find it anyways. So my difference in magnitude between meters and kilometers is 1 times 10 to the third meters per 1 kilometer, right? Now, if I go ahead and do my unit cancellations, I get to go cross off, cross off. Now, my units at this point are in meters per hour, right? So I've done one unit conversion. My next step is to convert hours into seconds, right? So I'm going to put another line on my table. I'm going to put hours here and seconds there, right? So again, what I'm doing here is I have hours on bottom, hours on top. That's going to allow me to make that conversion, right, into seconds. So what I have to then figure out is, am I going to be multiplying, dividing? What am I doing here to convert seconds into hours, or hours into seconds in this case, right? So we know that seconds are smaller than hours. All right, so in 1 hour, essentially the way we can look at that is how many seconds do we have? And that's a pretty simple math. Most of you guys know that there's 60 seconds in a minute, 60 minutes in an hour. So on my calculator, I'm just going to push 60 times 60, gives me 3,600 seconds. I'm going to go ahead and write that. 3,600 seconds. All right, so now I get to go cross off my hour, so my units that I'm looking at now is meters over seconds, which is what I want my answer to be in. So at this point, I get to make a fairly simple, calculation problem here, equals. So what I'm going to do is I'm going to multiply 45 times 1,000, right, or 45 times 1 times 10 to the third, get that answer, divided by now 3,600. And so when I do that on my calculator, 45 times 1,000 is 45 divided by 3,600 equals 12.5 meters per second. Okay, now I've got 12.5 meters per second. What I'm going to do next in this case is round this according to sig figs. So we're not letting those sig figs go away. We're always thinking in terms of sig figs, right? So in my numbers that I use for calculating, I have 45 kilometers per hour is the number I was given. I have 2 sig figs there. 1 times 10 to the third, that's exactly 1,000. So I don't use that conversion there for sig figs. 3,600 seconds also has 2 sig figs. So I'm going to round this to 2. So I'm going to make that 13 meters per second. Okay. And that's the answer I would report on my test, because that says 2 sig figs, 2 sig figs. All right. Next example. So I have 35.24 grams of gold. So that's my known quantity. All right. Right. If the density of gold is 19.3 grams per cubic centimeter, what is the volume of my sample of gold? So this is kind of a tougher way of looking at things, because what we have to do is consider what units do I want in my answer. So I want my answer to show volume, right? And so of the units given up here, cubic centimeters is that measure of volume. All right? So what I'm going to do here is I'm going to take my known quantity, which is 35.24 grams of gold, right? So I'm going to go 35.24 grams over 1, right? Just like we learned before, we always take our known quantity in a fraction over 1. Now, the other conversion I have is 19.3 grams per cubic centimeter, all right? So what I want to do here is I want to get my answer to have volume. So I want my answer to be in cubic centimeters, which means I'm going to probably get my cubic centimeters on top and my grams on the bottom. So in this case, right, I have 19.3 grams per cubic centimeter, right? So I'm going to put cm cubed up top for cubic centimeters, grams there, right? Now, I have to figure out what to do with this 19.3. That 19.3 is referring to the number of grams. So I'm going to attach that number just like that. Okay? So it's 19.3 grams per 1 cubic centimeter. So the 19.3 in this case needs to accompany my gram based on what that tells me, right? Now, using unit conversions, I get to cross off my G. My answer will now be in cubic centimeters. All right, so now it's a simple division problem. 35.24 divided by 19.3, and I get a big, long, ugly number, 1.825906, and so on, right? Now, how many sig figs do I get in my answer? I have 3 there in that conversion factor. I have 4 there, so I'm going to put 3 sig figs in my answer. So I'm going to go 1, 2. I'm going to round that 2 up. So I'm going to say 1.83 cubic centimeters will be my answer that I would report on a quiz or test. All right? So again, I'm dealing with more than one unit because I have grams and cubic centimeters, right? I'm canceling out the units I don't want by crossing them on both sides of a fraction, right? Putting the units I do want on top. All right? Now, what if I have different types of units? All right? So rather than going from meters to kilometers or millimeters to kilometers or centigrams to kilograms and so on, where grams is always the same type of unit, what if I want to go from pounds to kilograms? Or what if I want to go from meters to miles, etc.? All right. So in that case, I'll always give you a conversion factor to use. So let's start with this. Let's say I am driving 70 miles per hour, right? So you're on the highway in Washington State, the interstate highway, speed limit 70 miles per hour often, right? But let's say, just for the heck of it, I want to figure out what my speed is in meters per second. Okay. So here I give you 1 mile is equal to 1.61 kilometers. All right, so this is going to be a complex problem because what I know is 70 miles per hour. So I'm going to go ahead and write my known quantity, 70 miles over 1 hour, right? So that means in 1 hour's time at that speed, I will travel 70 miles. All right, so what I need to do is I need to somehow get my miles into meters and hours converted to seconds. And again, like we did on the page before, we can do that whichever order we want. But I'm going to go ahead and go miles into meters first. All right, so what information did Mr. Huderberg give you that will help you go from miles to meters? My conversion is 1 mile is equal to 1.61 kilometers, right? So what I'm going to do first, I'm going to go miles into kilometers and then kilometers to meters. So this is going to be a multi-step problem. That's why I'm starting to add some extra length on my line here. All right. So I want to go from miles to kilometers first. So km top, miles on bottom. Okay. Now the 1.61 accompanies the kilometers. So I'm going to put that number with the kilometers over 1 mile. Right. So what I can do now, I can cancel my miles. Now my answer, if I were to stop here, would give me kilometers per hour. I want to get to meters per second. So my next step then is go kilometers to meters. So I'm going to go km on bottom and meters on top, right? And so in this case, I'm going down the table, so I'll be multiplying, right? So I'm going to be going 1 times 10 to the third, which is my difference in magnitude between kilo and the base unit, over 1 kilometer. One more step. Cancel kilo. I'm in meters per hour now. So I have one more conversion to make, which is converting hours into seconds. Now we already did this conversion on the earlier page. So if you recall, 1 hour is equal to 3,600 seconds, right? So I want to have seconds on bottom, hours on top, right? Why did I put hours on top there? Because it's on the bottom over here. Right? And in order to cancel, they have to be on opposite sides of this line that goes across. All right? So 1 hour is equal to 3,600 seconds. Now I get to cross off my hours, right? So remember what, we go back to the problem. I wanted my answer to be in meters per second or meters over second. If I look back at my table, I have meters on top, seconds on bottom. So it looks like all of my conversions are ready to go. So what I'm going to do, I'm going to multiply 70 by 1.61 by 1,000, get that number, and divide by 3,600. So 70 times 1.61 times 1,000 divided by 3,600. And I get 31.30555 repeating. Right? So on. Okay? Now, and that will be meters per second. Now, I did not measure anything nearly that accurately, so let's go back to our numbers. Right? This has 3 sig figs. This is infinite number of sig figs. This has 1 sig fig. This one has 2. So, my lowest number there is 1 sig fig. So I have to round this to my very first significant digit. So that's going to be that 3. So 1 rounded down, so I'm going to say that is 30 meters per second as my final answer. Okay? Okay, so what did I do here? I started with my known quantity, 70 miles per hour, so 70 miles over 1 hour. I knew that I wanted to have my answer in meters per second, so that told me I had to go miles to meters and hours to seconds. All right. So in order to get from miles to meters, I had to do a conversion from the English system to the metric system first. And the conversion I was given put me in kilometers. So I went miles to kilometers first, then kilometers to meters. All right. So that gave me the units I wanted on top. There's my meters taken care of. Then I went from hours into seconds by putting the hours on opposite sides of the fraction and using that conversion I figured out on the last problem on the previous page.